This is a recast of the 5,400-word piece, Deep Learning Models in Machine Learning from Schneepat AI. This article is about the fundamentals, applications, challenges and opportunities of deep learning models in machine learning. Let's listen in.
As the article states, machine learning is an incredibly active field of research that is receiving a lot of attention. One of the main technologies powering machine learning is deep learning.
Deep learning is based on artificial neural networks that attempt to mimic the workings of the human brain. What's really interesting about these networks is that they are able to process large amounts of data and identify complex patterns.
It's no surprise then that deep learning models are being used in a variety of industries including healthcare, finance, transportation, and security. It's clear that these models have the potential to greatly improve data analysis and decision-making in many areas.
That's right, and in this essay, we'll be exploring the fundamentals of deep learning models in ML, discussing your applications, and examining some of the current challenges and opportunities in this area.
A key concept to understand when it comes to deep learning models is neural networks. Neural networks are a type of artificial intelligence that seeks to mimic the functioning of the human brain. They are made up of interconnected nodes, or neurons, which are organized into layers. Each neuron has an associated weight, and the network uses these weights to adjust its outputs in response to input signals.
It's also important to note that neural networks require extensive computing resources and large amounts of labeled data during training, so that they can be used effectively. Researchers are exploring new techniques like transfer learning to try and overcome these challenges and make the process more efficient.
Now, let's look at the different types of deep learning models. One popular model is the convolutional neural network, or CNN. CNNs are used for processing images and videos and are designed to extract spatial features from the data. They consist of three types of layers: convolutional, pooling, and fully connected.
Another type of deep learning model is the recurrent neural network, or RNN. RNNs are used for processing sequential data like text, speech, and time series data. An important feature of RNNs is their ability to store the previous state, which allows them to model sequences of arbitrary lengths. The long short-term memory, or LSTM, is a type of RNN that helps to reduce the problem of vanishing gradients.
Another type of deep learning model is the generative model. Generative models are used to generate new data by learning the underlying structure of the input data. Variational autoencoders, VAEs, and generative adversarial networks, GANs, are two popular generative models used in deep learning. While VAEs are used for probabilistic modeling, GANs are used for generating realistic synthetic data.
An area of machine learning that still needs more research is interpretability. Due to their complex architecture and numerous layers, deep learning models can be hard to interpret or explain. This is especially concerning in sensitive or high-stakes fields where accurate and transparent decision-making is key. To improve interpretability, researchers are exploring methods like visualization of activation patterns or creating models that explicitly incorporate human knowledge and expertise.
As for advantages of deep learning models, one key benefit is their ability to learn complex patterns and relationships in data that may not be obvious to humans. Deep learning models can also handle large volumes of data and can adapt to changing environments, making them very versatile in various applications. And finally, they are generally more accurate and efficient than other ML models, which can save time and resources in the long run.
Now that we've talked about the general benefits and challenges of deep learning models, let's go into specific applications. We'll start with image and object recognition. Deep learning models like convolutional neural networks, CNNs, and region-based CNNs, RCNNs, are used for recognizing objects or items in images. Some potential applications of these models include facial recognition, surveillance, and self-driving cars.
Another area where deep learning models are making a big impact is natural language processing, NLP. These models can be used to process natural language inputs such as text or speech to understand the meaning of words, their context, and the relationships between them. This can open the door to more efficient customer service, better search engine results, improved healthcare outcomes. The list goes on and on.
And finally, let's talk about speech recognition. This is a critical aspect of NLP, as it allows machines to actually understand spoken language. This can be used for voice-controlled assistants like Siri or Alexa, voice banking, automated customer service systems. The possibilities are endless.
So that's just a few of the ways deep learning models are being used to improve our lives. But what are the challenges and limitations to this technology?
That's a great question. One of the biggest challenges of deep learning models is the need for massive amounts of training data and computing power. Deep learning models require large amounts of data to accurately learn complex patterns and relationships within the data, and they also require significant computing power to accelerate the training process. This can be expensive and time-consuming, especially for small companies with few resources.
Another limitation is that deep learning models suffer from interpretability problems. They can produce incredibly accurate results, but it can be difficult to understand why the output was produced, which is a critical factor in many areas, such as healthcare and law enforcement.
That's right. So while deep learning has tremendous potential, it's important to remember that there are still challenges and limitations that must be addressed before it can be fully embraced across industries and sectors.
Absolutely. One of the main challenges is the so-called black box problem, which refers to the difficulty in understanding how deep learning models reached a certain decision or prediction. This opacity makes it hard to explain the model's behavior, so any decision it makes can be difficult to trust.
Right. And this can potentially lead to bias in the model, since the data used for training a deep learning model can also be biased. For instance, this type of model might struggle to recognize individuals of certain demographics due to the data used for training.
This is a valid concern, and it's something that must be taken into account when dealing with sensitive applications.
That's why there are techniques being developed to tackle the black box problem and create more interpretable models. For example, explainable AI models and visualization tools are being developed that can provide insights into deep learning decisions while preserving their performance.
Exactly. Additionally, we can expect further developments in deep learning models in the future. Semi-supervised and unsupervised learning techniques will likely gain more attention, while the potential to integrate with other emerging technologies, such as quantum computing and blockchain, could further enhance their capabilities.
That's true. And finally, there are some emerging trends in the application of deep learning models. Natural language processing, image recognition, and speech recognition are just some of the areas where deep learning models have been used and will likely continue to be used in the future.
Right. With the rise of big data, we can expect deep learning models to be used more frequently in data analytics as well.
Indeed, deep learning has tremendous potential and its applications have only just begun to be explored.
Right. So let's take a look at what these models do and how they are being applied.
Deep learning models are computer systems that use multi-layered representations of data to recognize complex patterns and make predictions. They are used in tasks such as image recognition, natural language processing, and speech recognition.
That's right. And the main advantage of these models is their ability to learn from large data sets and adapt to new and challenging environments.
Exactly. This has enabled them to be used in a variety of applications, such as autonomous vehicles, healthcare, and finance.
Yes, with the potential to revolutionize these industries, it's no surprise that deep learning models are becoming increasingly popular in machine learning.
Absolutely. But there are still some challenges to using deep learning models that need to be addressed. For instance, they require large amounts of labeled data for training and also require a lot of computational power.
That's true. But the field of deep learning is constantly evolving. And new research is emerging regularly, providing us with new techniques and architectures on the horizon.
Right. With continued research and development, the potential of deep learning models can be maximized and the benefits they provide can be extended to a variety of fields. So it is essential to keep investing in this area to create the necessary foundations for an AI-rich future.
Agreed.